So today is a big day. We finally get to learn SOHCAHTOA. SOHCAHTOA. What SOHCAHTOA is a representation of sine, cosine, and tangent. Sine, cosine, and tangent are ratios of sides of a right triangle. So you recognize the word hypotenuse, right? When you look at a right triangle, you know that the hypotenuse is the longest side, the side across from the right angle. We often use the letter C for hypotenuse. And then we've always called these two sides A and B, and we've called them the legs. Now we're going to use the word either opposite or adjacent, depending on which angle we're talking about. So if we're talking about angle A, little a is opposite, B is adjacent. And if we're talking about angle B, little b is opposite and A is adjacent. The sine of an angle is always the ratio of the side opposite to the hypotenuse. The cosine is the ratio of the side adjacent to the hypotenuse. And the tangent is always the ratio of the opposite to the adjacent. Opposite over adjacent. Now these ratios only work for right triangles, so we'll only have right triangles. And the easy way to remember this is SOHCAHTOA. So, of course, stands for sine is opposite over hypotenuse. Ka is cosine adjacent over hypotenuse. And toa is tan is opposite over adjacent. So we start with what we call an easy one, right? This is a 3, 4, 5 right triangle. We know that this works in the Pythagorean theorem. We know that it's a triple, that 3 squared plus 4 squared equals 5 squared, right? We know that 5 is always the hypotenuse, so a lot of times I just write an h by the 5. And then you'll notice that first we ask for 3 trig functions of angle A, and then 3 trig functions of angle B. The hypotenuse never changes, but the opposite and the adjacent will change. So if I'm talking about angle A, the side opposite is 3. So the sine is opposite over adjacent, or 3 over 5. The cosine is adjacent over hypotenuse, or 4 over 5. And the tangent is opposite over adjacent, or 3 over 4. If I switch to angle B, so the hypotenuse is going to stay the same. We use a different color here. The hypotenuse is going to stay the same for angle B, but now the opposite side is going to be the 4, and the adjacent side is going to be the 3. So the sine of angle B, opposite over hypotenuse, is 4 over 5. Adjacent over hypotenuse is 3 over 5, and opposite over adjacent is 4/3. So you'll notice some patterns. You'll notice that the sine of A is always going to equal the cosine of B. That will always be true. Similarly, the cosine of A is always going to equal the sine of B. And that's just because the opposite and adjacent switch spots. If we do the next one, you notice it's missing a side, right? And it says use the Pythagorean theorem to find B. You might remember that by heart. Do you remember the other side in a triangle with 5 and 13? We're showing the work anyway, but you're right. The B turns out to be 12. So B equals 12. I like to label it, so the hypotenuse is 13. That's always going to be. Now side A, or angle A, is over here, so the side that's opposite is the 5, and the side that's adjacent is the 12. And remember, adjacent just means next to, right? And the hypotenuse is kind of its own thing, so that never counts as our adjacent side. Sine, therefore, is opposite over hypotenuse, 5 over 13. Cosine adjacent over hypotenuse, 12 over 13. And tan is 5 over 12, opposite over adjacent. If I switch now to angle B, now the opposite side is 12 and the adjacent side is 5. So the sine of angle B, 12 over 13. Cosine is 5 adjacent over hypotenuse, 5 over 13. And then opposite over adjacent, 12 over 5. And again, you can see that the cosine here matches the sine there and vice versa. Not too terrible, right? So here we're going to really be specific with our triangle. It's not just a right triangle, but it's a 30, 60, 90 triangle. All the sides are given to you. The 2 is always the hypotenuse. Instead of saying angle A, now it's going to say actually the 30-degree angle. So in the 30-degree angle, the 1 is opposite and the root 3 is adjacent. So the exact sign would be 1/2, opposite over hypotenuse. The exact cosine is root 3 over 2, and the exact tangent is 1 over root 3. If I switch to the 60-degree angle, now the opposite and the adjacent change spots, so the square root of 3 is opposite and the 1 is adjacent. So the sine of a 60 is root 3 over 2, opposite over hypotenuse. Cosine is 1/2, adjacent over hypotenuse. And then the tan is root 3 over 1, which I could write as root 3. Those are exact answers, right? The reason we differentiate, as we have always done, between exact and approximate. Exact always has a symbol, so you see the square root symbol. And the approximate, as has been done before, will be done on our calculator. So if I type in sine of 30 degrees, sine of 30, I'm going to get, okay, good, I'm glad this happened. I should have gotten 1/2. But the fact that I didn't is telling me I'm in the wrong mode. So you have to make sure that your calculator is in degree mode. So I'm going to scroll over to degree and hit enter. Your calculator might have already been in degree mode. Sine of 30 is 0.5. So the exact answer is 1/2. The approximate answer is 0.5. I think we agree that those are the same. Now that my calculator is in the right mode, I can keep on going. Cos of a 30 is 0.866. It says round to the nearest hundredth, so that's 0.87. And then tan of 30 is going to be 0.58. Now just to show that that's the same, for example, here I had 1 divided by the square root of 3. If I go 1 divided by the square root of 3, where's my square root? Square root of 3, and compare those, you'll see that it's the same. So this is the exact answer, this is the approximate answer. Same thing's going to happen for the 60 degrees, right? If I want to type in the calculator 60 degrees, sine of 60, 0.866, and I can compare that with square root of 3 divided by 2. I have to close the parentheses there, and it's going to be the same thing. So this is going to be 0.87. Similarly, if I type in cos of 60, I'm going to get 1/2. I'll do that real quick. Cos of 60 is 1/2, of course, and tan of 60 is 1.73. And that's the same thing as square root of 3, if I were to type that in. Oops. Square root of 3. Same thing. Perfect. Now we move on to the 45, 45, 90. Now this is nice because it's an isosceles triangle, so it doesn't matter which 45 you choose, the opposite and the adjacent are all going to be 1. So the sine is going to be 1 over root 2, hypotenuse is root 2, cosine is 1 over root 2, and the tangent opposite over adjacent is 1. If I go back to my calculator and I type in sine 45, I'm going to get 0.71. I'm just going to do them all here real quick. Cos 45 is also 0.71, and tan of 45 is going to be 1. So I'll just copy those decimals down then. 0.71, 0.71, and 1. Okay. The last one's like, this is where you're kind of using the sine, cosine, or tangent. So this one here, you need a calculator for. You need to label your sides. So that's obviously the hypotenuse, and the x here is opposite. So you have to decide if it's what we call a SO problem, a CA problem, or a TOA problem. People always ask, how do you know? Well, by labeling my picture with the O and the H, and looking back up at my definitions, which one has an O and an H? So this is a SO problem or a sine problem. Sine of 35 in this case is equal to x over 22. And this is a little mini algebra problem that I solve by multiplying both sides by 22. And I solve that on my calculator by literally just typing in 22 sine 35, 12.62. 12.62. Oops, 12.62 equals x. Now, you know I'm fair, right? So I'm probably going to have one of each. Like that was a SO problem. This has got 9 as the hypotenuse compared to the 20 degrees. That's the adjacent. So would that be a SO, a CA, or a TOA? A SO, a CA, or a TOA with an A and an H. You're right, it's a CA, or a cos problem. So the cos of 20 is equal to y over 9. I'm going to solve this by multiplying both sides by 9. I'm going to come over to my calculator and type in 9 cos 20. 9 cos 20, 8.46 equals y. The last one here, it's a little story problem, but you can see the pictures drawn for you. You've got the angle of 54. You've got the h, which this is a little confusing because it's not h hypotenuse h. The h is actually standing for the height of the building. And it's actually opposite the 54, and then the 60 here is a adjacent. So opposite and adjacent, well, there's only one left, and it's tan. So the tan of 54 is equal to the opposite over the adjacent, or h over 60. And I'm going to multiply both sides by 60. So I'm going to type in my calculator 60 tan 54. 60 tan 54, 82.58. Always round to 2 places after the decimal, 82.58. And since this was a story problem, I'm going to add on the feet is equal to h. So I know those 3 at the end were a little bit different, but we've got the SO, CA, and TOA, and that's how we use it.